Mesa's proven DryCal technology is a revolutionary piston-prover gas flow measurement system. DryCal technology doesn't rely on soap bubbles for measurement, oil or mercury to form a gas-tight seal, or non-primary thermal mass flow or differential pressure technologies that must be backward calculated to obtain volumetric flow. Measuring gas flow is elusive. While there are rulers to measure distance and watches to measure time, there is no one-size-fits-all tool to measure gas flow. Flow for gas is usually measured as volumetric flow or mass flow. DryCal calibrators directly measure volumetric flow rather than using an indirect method of heat transfer or pressure drop against a restriction used by most mass flow-based systems. The key to understanding gas flow measurement starts with the knowledge of the 7 SI base units that have been quantified and refined worldwide, each of which have exact values that are unlikely to change. These SI base units are also called the primary units of measure and include length, time, mass, electric current, thermodynamic temperature, amount of substance, and luminous intensity. Since there's no SI base unit for the direct measurement of gas flow, we use the base units of time and length to calculate flow rates. A flow rate is defined as the time it takes a quantity of something to cross a defined boundary. In this case, the quantity is a volume, such as cubic centimeters or cubic inches, over a unit of time, such as seconds or minutes. To illustrate this operating principle of DryCal gas flow calibrators, imagine you have a bucket with a known volume and a stopwatch. Imagine starting the stopwatch when water begins to flow into the bucket, and stopping the watch when the bucket is full. Combining the volume of the bucket with how long it took to fill the bucket gives you a volume over a measured time, or a volumetric flow rate. DryCal technology uses a glass tube with a calibrated volume instead of a bucket, and a moving piston that triggers light sensors instead of a stopwatch. A valve closes, diverting gas into the measurement cell. The piston then accelerates upward to the timing starting point, where measurement timing begins. The timing stops after the piston reaches a location of known volume. The gas is then released from the flow cell, allowing the piston to drop to the bottom. The system instantly resets, just in time for the next reading. However, remember that gases are compressible. Remember also that changing the pressure or temperature of a gas changes the volume of that gas. In fact, a pressure change is needed to make gas flow in the first place. So as gas flows, it inherently changes volume. If we measure gas pressure and temperature during measurements, we can calculate the volume of the gas at a defined pressure and temperature. This is known as the process of standardizing gas flow. The standardized flow equation, shown here, illustrates that standardized flow equals the volumetric flow rate times the gas pressure during the sampling period over the gas temperature during the sampling period times the standard temperature over the standard pressure. Many DryCal calibrators take care of this standardization equation for you. Pressure and temperature transducers in the flow stream allow conversion of the volumetric flow to standardized conditions. With proven DryCal technology products, customers receive accurate, directly traceable primary flow measurements that are fully supported by our leading ISO 17025 laboratory accreditation. For more information on DryCal technology products, visit us today at drycal.com.